Okay, so today we're going to turn fractions into percentages. We have not really done that much before, so quick reminder, what are percentages about? What are percentages always?
The amount of something you get.
Out of how much though? Percentages are always
Out of 100.
out of 100. So we had an earlier in the year lesson where they gave us some fractions that were out of 100 and we made percentages, but that was kind of artificially easy. Like if I'd say 28 over 100, what percentage is that?
28%.
28%. No, we did a whole lesson of that. It was kind of silly. 7 over 100, what is that? 7% is like too easy, too good to be true almost. Today they're going to give you a little bit more realistic questions where none of these fractions are right now on top of 100. They're just normal, other, more common fractions. So I've got three systems for you. There's a system that'll always work, but it's a little bit more work. There's a sometimes going to work trick I can show you that's a lot quicker. And then I've got an often it's going to work sort of trick. Does anybody have a way to make 5/12% using knowledge that's in your brain from other years? Any memories of how to turn fractions into percentages? So I'll just tell you. We're going to take the bottom number and divide it into the top number like we have for a lot of other things. The fraction bar is meant to divide for a lot of things we've done. But because it's percentages, we're going to make an adjustment and take the top times 100. Percentages always have to use 100. So if I want to do 5/12ths, I'm going to put 12 out, I'm going to put 5 in, but not just normal 5, I'm going to have to make the 5 be 500. And then we'll just divide. This will work every time. That's the good news. The bad news is people don't usually like the long divide that much. I think that's not most people's favorite thing to do in their day. But it'll get us there. So 12 into 50, just yell. 4 12s makes 48. Subtract gets you
2.
2. Drop the 0. 12 into 20.
1.
1 gets you 12. Remainder
8.
8. At which point now you have two choices. This could either be 41 and a fraction, or it could be 41 and a decimal. If I decide to do a decimal, I put a decimal in there, and what would I add on?
8.
A 0. And I'd have to divide till it repeats or ends. You can do that. I don't want to do that. Because sometimes when we've done this decimal division before, sometimes how long does it take before it repeats or ends? It takes a while sometimes. So I'm more of a fan of give up and make a fraction. We got a remainder. Can anybody tell me what our give up and make a fraction would be? 8/12ths. Is 8/12ths the best fraction there? What's better than 8/12ths? 2/3 would be the best fraction. So 41 and 2/3%. The 2/3 happened, we're going 8/12ths, always the remainder on top of the divisor, but then he reduced it. We always want to reduce from. That system will always work. Okay, so if you want one thing that always works, do that and you can ignore me the rest of the period. That'll get you there, but I've got some faster ways to do it. So 8/15ths. If you wanted to do 8/15ths, how would you turn 8/15ths into a percentage? 15 goes out, 800 goes in. So 15, count by 15s and get as close as you can to 80. How many 15s can get you close to 80? 5. Where does 5 15s land you? 75. Subtract gets you 5. Drop the 0. And now how many 15s can get us close to 50? 3. 3 15s lands you on 45. Remainder 5. Fraction, what would be the first fraction that pops to our mind using the 5? 5 15ths. Is 5 15ths the best we can do? No, what's better than that? 1/3. So 53 and 1/3%. If you're not comfortable at all with fractions, you could throw a decimal, you could throw some zeros, you could just go till it repeats, put bars on things, that's fine. I don't like to do that personally, but you are welcome to do that if you like that better. That's totally fine. Percents can do fractions, percents can do decimals. Question about strategy 1 that would always work. Okay, I've got a different strategy. Okay, if you wanted to do this one by the same strategy, who would divide into who? What would be our division on this one? If we tried it, I'm not going to do it the same way, but if I wanted to do it the same way, what would the division be on this?
20 over 700.
20 would go into 700. 20 would go out, inside, put the 7, add on the double zeros, because we're going times 100. If you go 20 into 700, you'd be fine. But I have a different way I can do this one in a much quicker way than long dividing. Does anybody have a suggestion on a trick we could use here to try to get this percentage? Let me give you a little hint. What was percentage about again? Well, what's the meaning of percentages?
Oh, I was just gonna say, how much times 20 goes into
Yeah, because all percentages count out of 100. This fraction can be made to be out of 100.
Oh, name change.
Okay, so yeah, it's the name changer machine. So if you want to use the name changer machine to make things be out of 100, that's going to be a quicker way to go. 20 can turn into 100 if we multiply by 5. So the top would be
35.
35. And that is now
35. No. Out of 100. 35%.
35%. Okay. Can 25 be made into 100? Yeah. So multiply by 4. So the top
44.
4. So the result
44%.
44%. 50. Can that be made 100?
Yeah.
Yeah. Multiply by
2.
2. Makes the top.
62.
So
62%.
that doesn't always work. That sometimes works. If it works, that's quick. Okay. Back to where we started. Can 12 be turned into 100? No. Can 15?
No.
No. So that's why we didn't do that over there. You can't turn everything into 100 evenly by multiplying, but sometimes you can, and if you do, that's the quickest thing you can do. Question about that?
Do you usually like what ends in 5 and 0? Or?
Anything that divides into 100. So 10s could do that. 10s, 20s, 25s, 50s.
Oh, I thought
Fives.
there could be like a strategy like. if
This
anything-
has to divide it evenly into 100.
Oh, 'cause I was gonna say like a strategy like anything that ends in 5 or 0.
Yeah, well, because 15 wouldn't do it.
Oh, that's right. Yeah.
Question about that strategy? Okay, could you turn me a little bit? So this group, I've got a trick that I'll say often works, especially in your book. I'm going to work this way and then through the bottom back that way. I'll make sort of like a reverse L shape through these. What can we do about these? Why are these maybe like a familiar thing to us that might have a trick?
Memorize it and like
Yeah, using our
chart.
chart. So one thing you might be able to do is use your chart to get yourself a decimal. And then how do we change? Well, let's start with that. 3/5, somebody? 0.6. 3/4, just yell.
75.
0.75. 5/8. Anybody? Just yell if you know them.
450.
We'll come back. 8/9, anybody? Oh, you remember the
25.
625 is 5/8. 8/9. Remember, he said 8/9.
Ah, wait, 0.8. Oh, 0.8 with line.
It is a line over it. So then let's talk again. Our goal isn't to make these decimals. Our goal is to make these percentages. How can you take decimals and make them percentages? What did we do with those?
Moving over
How many?
twice.
Twice. We're going to go right 2 places. So we've got a decimal, send it right 2 places. That is now 60% because we have that empty, empties become zeros. If you remember your chart, that'll be the quickest way to do it. What if you forgot your chart?
Balance it out.
Yeah, go back to where we started, do the division. The division will always work. But if you happen to notice a name changer opportunity, it'll be quicker. If you happen to be looking at a fraction and you're like, oh, I know this one, that's going to be a little quicker. So the 0.75, bounce it right twice, that's going to be
75%.
75%. this, if you bounce it twice, what's that gonna be? Somebody with a hand this time instead of just yelling.
62.5.
That'll be 62.5%. Somebody with a hand on this one, because it's different, if I bounce that twice, what's up with that? I'll say this, it's not 80, so don't say 80, say something other than 80. Your opinion there?
88.
That's warm,
81.
that's colder,
88 with a line over.
that's warmer,
Is it 89 with one?
it's not,
80 with the line over?
it's colder.
Wait,
Would it be .888 with a line over?
Well, we're bouncing it twice though. So the decimal's right here, right now. We're gonna bounce it twice.
88.8%.
That is
The line
correct.
over the decimal.
There's our hit. It's 88.8
Where's it?
combined on the 8%. Here's the rule. The bar can only be written once you're in the decimal position. So you can't ever put a bar over a whole number. So we have to think about what this means. 0.8 with a bar, what does that really mean? I wrote that in like a shortcut way, but what does it really mean?
It just like keeps
It
continuing.
keeps going. That's really .8888888.
88.
Okay, that's what that really is. So if I bounce it twice, it's not an 80. This empty isn't a 0. This empty is an 8, because that 8's going to repeat. It's an 88. But there's still a decimal, and there's still a lot more 8s that are coming. So if your chart had a bar, and you move the decimal over, your answer still needs to have a bar on it. It's still got to have that repeat going. Question about that idea? Okay. Am I still on screen when I go this way?
that's the only one.
Okay, that's, yeah, we'll rotate a smidge. So 5/11ths. What was 5/11ths on our chart? And again, if you forgot the chart, what's the bailout? Hey, I forgot my chart, I can't do this chart trick. How can you do them all? Yeah, we just go divide. We divide, that'll always work.
0.45.
It's 45, the line go on one or both of them? It covered both. So what does that really mean? What does 0.45 with the bar really mean if I wrote it a longer way?
45.
45. So if I bounce it twice, what is that?
45.45%.
That is correct. We'd have a 45, a decimal, and another 45. If the chart used to have two numbers under, our new answer still has to have those same two numbers under there. 2/3. What was 2/3 on our chart?
0.6 with the line over?
6 with a line over it, which you have to remember
6, 6,
means
6,
there's
6.
like a million sixes. If it helps you to write a million sixes, write them. If you can picture them in your mind, you don't have to write them. But we're gonna bounce that twice. So what are we looking at?
6.6 with a line over?
That's correct. Question about that one. 5/6. What's 5/6 about? Do you remember 5/6?
0.83 with the line over 3.
It is a .83, but the line's just over the 3. So if I wrote that a longer way, what does that mean that one looks like really in a longer form?
Oh, 8, 3, 3, 3.
Yeah, it's a single 8 and then a bunch of 3s. So if we go over twice, what are we looking at once we've gone over twice then?
8, 3, 8, 3.
Just a 3 with the line. Again, here's the rule. If the bar used to cover one number, the bar should still only cover one number. The amount of numbers the bar covers isn't going to be changed by us moving around. Am I still on screen for 5/7?
Oh, yeah.
Okay, so 5/7, anybody remember what 5/7 was about? That was a long one. And again, if you forget them, you're on a test, you don't have a chart, can't use it, you don't remember it, just go ahead, divide. Divide will never fail you. Anybody remember the long decimal for that?
Is that, 0.57?
That's the 4/7. You're close.
0.571428.
That's a 4/7.
0.71485.
714.
85.
No, not after the 4.
2-8?
285. Agreed with that. If we wrote this a longer way, what does this really mean is happening? There's a 714,285. Then what's coming?
Wait, the 1-4?
714.
Another 714,285. And then another,
714.
and I don't really want to write that all day, but they just keep coming. So if we bounce that twice, what are we looking at once we bounce that twice? Yep.
The line over all of it?
And what do we start with though?
7,
7, then,
1,
then,
4,
not yet.
7, 1 decimal?
There's a decimal, yes. So we got a 71, then we got a decimal, then
4, 2, 8, 5. The line over all of it?
not quite,
Line over the 4 to 5.
not quite.
Wait, 4, 2, 8, 5, because the line has to be after the decimal?
It's getting warmer.
And 7 1.
Yeah, we need more numbers. Okay, so we need our bar to cover, the bar can only cover our decimal positions. How many numbers did the bar use to cover?
6.
6. It still has to cover 6 numbers. We can't change the length of that bar. So after 4, 2, 8, 5, we've got 4 positions. Who comes after the 5?
7.
7. Who's after the 7?
1.
1. Who's after the 1?
4.
4. Well, we already got the 4. So we just need to work in another 7, 1. When we slid this decimal over twice, we sort of like uncovered the 71. We need to jam that at the back end. If you found that confusing, don't do it. Okay, what can always bail you out?
Box the top.
Blocks the top. Just go ahead. This one, we could go 7 into 500. So 7 into 500 here, this would be 7 gets us 49, gets us,
1, 10, 1, 3.
and then make a fraction. The fraction here would be
3 7.
3 sevenths. So if I say 71 point whatever, I'm right. If you say 71 and 3 sevenths, you're right too, because 3 sevenths is the exact same as this thing. It doesn't matter which of those you have. So if you're very chart comfortable, use the chart, move over to. If you're not chart comfortable, don't use the chart, just divide every time. If you're medium, well, kind of pick and choose. You know, if you're like, oh, I'm comfortable with 0.75, then use that trick. But if you start getting these bars and you're like, I don't want to move the decimal with the bars, that confuses me. Well, then don't do it that way. You can always divide. You can always divide to make a fraction into anything you want to make it, whether it's a percent or a decimal or anything else. The only difference about our normal division today, percentages have to do with hundreds. So the top has to get those 2 bonus zeros to make the division work. That's our day. Dividing will always work. Name changer machine's a decent shortcut. The chart is a decent shortcut. You pick how you want to do it. It doesn't matter to me. Question, any of that? Homework. Let's see where we are. Now it is a set again. There's a set GG in the back of these. So go into the back, set GG, no letters anywhere, just GG. GG is going to turn a bunch of fractions into percentages. And it's up to you how you want to do it. Some of these for sure can use the chart. Some of them for sure can't use the chart. Some of them for sure can use the name changer machine. Some of them for sure can't. If you want to use a different trick every time, great. If you want one way that'll always work and then you don't have to think, you just kind of like go on autopilot and just do repetitively the same process. The dividing process will work every time. So if you don't want to think and make choices, just divide it 25 times. If you want to get this done the fastest way possible, then I'd love to use the tricks. The tricks are going to be faster, but you've got to like think each time which trick will work. Question, anything?
Yes, please.
Go ahead.